molecular mass, what will happen to the rate of diffusion? Rate of diffusion will be what? High. And then time will be what? Low. Is that understood? Okay. Now, if we consider these two gases, A and B, don't write. I'll give you time to write. Now, let's say we have Ra, okay, it's now going to be equals to what? We compare, when we are comparing, we divide. So, Ra over Rb, that is rate of diffusion of gas A, divided by rate of diffusion of gas, what? B, will be equals to the square root of the density of gas B. Is that understood? Over the square root of the density of gas what? A. Now, the reason why we are doing this, from this law, which states that the rate is inversely proportional. That is, if you have Ra here, then the rate will be inversely proportional to the square root of its own density. Do you understand what I'm saying? Because look at this. If you make your constant here, from this point, K is equals to what? R root what? Root D. Are you with me? So from here, the rate of that diffusion of a gas multiplies its own vapor density, the square root of its vapor density. That is at constant temperature and pressure. Are we clear? Now, when you are writing the formula of two comparable gases under Graham's law, if you multiply this and this, let's cross multiply and see something. This will now be Ra root what? DA is equals to what? Rb root what? Db. That is what we are saying. So if you don't arrange the formula in this way, you may end up messing up everything. So that is why you cannot write Ra over Rb is equals to root dA over what? Root dB. No, this is completely wrong. Because we are dealing with density here. We'll be coming to a situation whereby the rate of diffusion of gas is directly proportional to their relative molecular masses. That is when you now have Ra over what? Rb is equals to root Ma over what? Root what? Mb. Now, this is correct. Is that okay? Because rate of diffusion of a gas can never be inversely proportional to the relative molecular mass. It is directly proportional. Isn't it? The lower the what? The lower the relative molecular mass. So, can we say it is direct or indirect now? Directly or indirectly? The higher the relative molecular mass, the lower the what? The lower the rate of diffusion, isn't it? The higher the mass, the lower. Is it direct now? It's direct. We cannot write it this way as well. So this one will now be what? MB as well. And this one will be what? ME. Do you understand what I'm saying here? Because, okay, the rate of diffusion of a gas, we said, is not directly related to the relative molecular mass. Is that okay? Had it be it is direct, it will be the lower the molecular mass of the gas, the lower the rate of what? Diffusion. But in this case, the lower the molecular weight, the higher the rate of diffusion. You see, they are not direct. There is inverse relation here. That is why when you are writing rate of diffusion of gas A will be equals to. Do you understand what we are saying here? So, but what if we come to another situation whereby we are dealing with volume? The higher the volume, if volume of a gas is high, what will happen to the rate of diffusion? The rate of diffusion will be higher or lower? Higher. How? 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 If we are dealing with volume, rate of diffusion Volume. Rate of diffusion. Volume. Volume is high. What will happen to rate? Rate will be low or high? U. Rate will be what? High or low? High. U. So why did you say rate of diffusion will be high? No idea. U. Why? Move faster, right? Okay. You. Are you with her? High volume, rate diffusion higher also. Yes. Okay, what of you, Fatih? What is your reason for saying the rate of diffusion will be slow or lower when the volume of the gas is high?
Because the volume is larger. The rate of diffusion is lower. Yes.
Okay. So, when you have larger volume, please, the rate of diffusion is what? It's also going to be high. So, which in this case you say square root of VA over what? Square root of what? VB. So, higher volume, higher diffusion. Remember we said diffusion is the movement of what? Particles from region of higher concentration to region of what?
Lower concentration.
Fine. Now, in this case, if you have more volume of the gas, it means you have what? The rate, in fact, you have more particles that will move faster. So the gas will spread fast. You can give an example. You have room spray, this perfume spray. You spray one, peep, and somebody there sprayed more than 5 times in that area.